really. So, and turn audio on, turn my screen on, and I'm going to put laptop on. All right. Sounds like I can hear myself. Everyone, make sure to mute. Hopefully, I don't hear myself on anyone's screen. Sounds good. Okay, cool. Sounds good. All right, guys. Welcome to this live lecture. I'm going to head over to our Canvas page. I'm going to navigate to Assignment 2.0 Intro to Rhino class. And I'm going to find this Rhino Level 1 training. Make sure you mute, please. I can still hear myself. All right. This is the Level 1 training English zip folder. I'm going to go ahead and click this one and download it. All right. It's going to appear here in my downloads folder. Okay. This is a zipped compressed folder. And you can tell by enlarging your icons, you'll see a zipped folder that has a little zipper on it. That always means it's a compressed manila folder. It's got tons of files. It's waiting to burst. It's had to be zipped up. So to unzip it properly, we're going to right click it. We're going to extract all. And then I want you to browse and find a location to where you're going to save all of these files. Okay. The way I like to think about it is where should I save it so I can remember where it is next time, right? Because you're going to need to access this thing throughout the entirety of the semester. So it would make a lot of sense for you to put it somewhere where you'll see it over and over and over again. Maybe mentally you'll know where to get to it. So I'm going to put it right here. I'm just going to put it right. Then click extract. How's the lag on this stream? Is it super slow? Is it decent? Just a little verbal. 30 seconds. Okay. I'll try to remember that as I go through it. I do have it up here. So this is actually streaming straight from my laptop. Okay. But if you do have any questions, just drop it in the comments in the comment section, and then I'll read it when I get to it. All right. So now that I have that folder, I've saved it under Fall 2025, under 171/172, and here is what it has. It's a models folder and then a PDF. Let's open up that PDF. I'll open up that PDF. And this is the Level 1 training manual. For those of you who are already taking Steve's Rhino 1 course, you're going to dip into this throughout the semester as well. I don't have enough time to really sit here and do the same exact lectures as you'll get out of that Rhino 1 class, where he'll actually guide you through those things, and those will be the main assignments. For me in this class, all I can do is refer you to these assignments. They'll help you understand the interface and understand the logic of Rhino. but this is not a Rhino course. Okay, my main focus here is going to be design and fabrication techniques. Rhino is one tool for outputting those design and fabrication techniques. You can use any tool that you want in my class. However, the only one I'll be able to teach you is Rhino. So I'm going to use Rhino Training Manual Level 1. I'm going to navigate to, I think it's page 26 on the PDF. So Rhino, the Level 1 training exercise 1 is Rhino Basics. The first thing you're going to want to do is, we've already done it, download the Level 1 training modules. Unzip the folder. We've already done that. Step 3 is from the file menu, click open. So I'm going to open up Rhino. Already got it open here. I'm going to go to File, Open. I'm going to navigate to where I saved it. Okay. And I'm looking for a model with the name Start. So I'm going to navigate down to Start. And I'm going to click it to open it up. Oops, that's the wrong one. I'm going to try that again. Whoops. Let's unmute, or let's mute. All right, Start. Turn me down. What's that? I'm just lecturing right now. Yeah, I'm just lecturing right now, you guys. All I want you to do is sit here and watch me tell the story about Rhino. Okay. You should have already done this assignment over the weekend or starting yesterday or this afternoon. So just watch the lecture. I'm just going to go through it very quickly, while the manual does go through it very sequentially. All right, back to it. Here I am. I've got 1, 2, 3 different viewports. On the left side, I have my top viewport. Okay. This grid that I'm looking at here is called the C plane. It is the construction plane. This perspective viewport also has a grid and a C plane, and then this front viewport also has its own C plane construction plane. So are all of these construction planes the same? No, they are not. If we think about the top viewport, we're looking straight down at these 5 items, right? There's 4 shapes and then one sort of ground. They call it a plane. So we got the cube, the cone, the cylinder, the sphere, and then we have a surface below it, so 5 items. In the top viewport, I'm looking at my object from above, and that grid that I'm looking at is basically just like the floor below us here in the studio. Okay? That is the construction plane in that viewport. In the perspective viewport, it's the same construction plane. Right? If we think about that cone in that perspective viewport, and the base of it is that circle base is on the ground, basically. Now when we look at the front viewport, right, we're looking at these items from the side as an elevation. Right. So the construction plane that we're looking at in the front viewport is actually, if you think about it, it's like a wall, right? Kind of like this big wall right in front of me here in the studio. So it's not the same as the C plane in the top viewport. It's different. The next thing we want to do is we're going to add a 4th viewport. So I'm going to go to View, Viewport Layout, and 4 viewports. If you're using a Mac, so far from what I've learned, you're going to have limited options here in the viewport section. Not sure why, but apparently Macs can't handle too many viewports or something like that. I'm going to click on 4 viewports. Oops, I just did the wrong thing. Let's do close viewport, and let's do 4 viewports. All right, Now I've got my four viewports. Got a top, got a front, and a right. So the C-plane in the right and the C-plane in the front are also different C-planes, okay? So if we stick with our analogy where this wall here in front of me is my C-plane as viewed from the front viewport, that wall over there is the C-plane as viewed from the right viewport, okay? So here's a front viewport, I'm sorry, front construction plane, right construction plane, and then down below me is the construction plane that I'm perceiving in both top and perspective. Okay. Does that make sense? So, thank you. Next thing we want to do is we're going to play with our different display modes. So here in the perspective viewport, if I just double click on perspective, it'll maximize that viewport so that way I can see it and not see the other viewports. And I'm going to right click it or click that little drop down arrow next to the word perspective, which is the name of this viewport, and I can change it from wireframe to shaded, right, to rendered, to ghosted. Ghosted's got a little bit of a see-through, some translucency. X-ray, technical, artistic, pen, monochrome, Arctic, and race traced. All of these are just different ways to view the same information. Each one of these display modes have their own specific settings. Okay. Certain display modes will show these little lines on the geometry. These are called your isocurves. Some of these display modes will show that. Some of the display modes will not. Some of the display modes will show these items as if there's a lighting. Some of them will display these objects based on their layered color. Some will show it based off of the rendered materials. And the material column here. Okay. That's all that these display modes are doing. All right. I'm going to skip over the rendering portion. This is a pretty old technique of rendering, but we've gone through all of these different display modes. Let's talk about navigating around the model. Here I am in the perspective viewport. I can use my scroll wheel and zoom in and zoom out into my 3D model. I can right click and drag. I'm holding down the right click as I move my cursor around. That's called dragging. Right clicking and dragging. And this allows me to perform an orbit. Yes? Need something? Okay. Oh, okay. All right. That's called an orbit. There is a pivot point somewhere here in the 3D model, and I can orbit around it to see every aspect of this 3D model. Now, if I want to perform something like a pan, this is what's known as a pan, and that's basically me just clicking and dragging my viewport to move myself around and view these pieces of geometry from different angles. So I can use a combination of these things to navigate around my 3D model. I can go below it, above it, far away from it, and close up. Okay. Moving these objects. We're going to practice moving these objects without using the move command. Now, if you select any of these pieces of geometry, and you see this goofy little thing here, the green arrow, blue arrow, red arrow, that is called the gumball. Okay. If you don't see it, that's because it's off. Down below is what they call a status bar. here my status bar, you'll visibly see a difference as you navigate through your file. Gumball is this one right here. If I click the word gumball, that'll actually turn off my gumball. Now I no longer see that red, green, blue arrow. And if I click that word gumball again, it'll turn it back on again. Okay. So I'm going to turn it off. I'm going to select my cone. And to quickly move it from one spot to another, I'm going to click and drag it. I'm going to left click and drag it into place. Okay. If I hit undo a couple times, I can actually turn on the grid snap. Okay. Here my status bar, grid snap. And the grid snap will enable me to snap to very specific points on this entire seaplane, on this entire grid. So now when I go to move my cone, you can see its movements are a little jagged, and that's because it's continually snapping to various snapping points on my grid. Same thing with the cylinder, and then same thing with my sphere. It's very slight, but as you can see, it is snapping. Now, if I look at it in the top viewport, you can see they're not properly aligned. So I can use this top viewport to my advantage to try to get all of these things all lined up, at least at the top. Maybe I scooch them over to space them out evenly. Okay, that's how you simply move items and pieces of geometry in Rhino. In the future, we'll be using a command to actually move those things. But for now, that's the basics. And with that in mind, I can navigate myself to any of the 4 viewports, click and drag certain items. I can move one on top of the other. I can move 2 things on top of another one. Oops. And then I can put my ball right on top of all those to perform a little balancing act, just like so. Did anyone try to replicate the castle from the level 1 training? Yeah? How did that go? Pretty good? Nice. I saw some of you. You guys were being pretty creative. Who had the snowman? Who did the little snowman? Who was it? Snowman's not here today? Okay. That was a funny one. All right. That's how to simply move things. If I wanted to copy objects, go File, Open, and open up the Start file again. I'm not going to do that. Click the box to select it. From the Transform menu, click Copy, click somewhere in the top view. So what we're going to do is, I'm going to go back to all 4 of my viewports by double-clicking that perspective viewport. I'm going to go to Transform. I'm going to go to Copy. I'm going to select the objects I want to copy. Here's a real important lesson that I'll introduce to you all early on. If I am making a selection window, let me go back just a little bit. If I am making a selection window, which looks something like that, just me clicking and dragging my cursor to make a window just like this. When I make a selection window that goes from left to right versus from going right to left, those are 2 different things. Let me explain. I've got these 4 pieces of geometry here in my top viewport. If I were to make a selection window by clicking and dragging from the left side to the right side, and let's say I left it right at this moment here, whereas you can see that 4th object is not fully encompassed by my selection window. If I let go now, notice that 3 of these objects are highlighted yellow. Okay. Notice the difference when I do it the opposite direction. Let's say I start down here, click and drag, and make a selection window of a similar size but going from right to left. Notice the difference there. Okay. Why does that happen? The simple answer is that when you go from left to right, only items that are fully encompassed by the selection window will be selected. Okay. So if I let go now, notice how that fourth object is not fully encompassed by that selection window. Therefore, only 3 items are highlighted. With that same logic, but going from right to left, right, that fourth item is, that sphere is still not fully encompassed, but I'm going to go right to left now. It is selected. Okay, there's a big difference there. Knowing how to do that is going to make you very efficient in your design and fabrication techniques. Okay, left to right, right to left, left to right, right to left. All right. Here is the castle. I don't expect you to make that castle, but if you already did, good on you. Let's move on to the next exercise. Panning, zooming, exercise number 2. So for this one, we're going to need the camera model. So I'm going to go to File, Open. I'm not going to save changes to this file. And this time, I'm going to navigate to the camera model. Here is the camera model. As you can see, you can use Rhino to create real smooth surfaces, just like this camera. But how do we get a look at this camera from all angles, all at the same exact time? Here in this top viewport, I'm going to click on this little drop-down arrow. I'm going to go to viewport layout, and I'm going to say split horizontal. Okay, that's going to split that one viewport into 2 horizontally. So now I have 2 viewports right there. And then this front one down below, I'm going to click on that arrow, viewport layout. This time I'm going to split it vertically. So I have 2 fronts. Now I'll go to my right viewport, viewport layout, split vertically. Now I have 2 right viewport layouts. Okay. So what's the point of having all of these? I've got 2 tops, 2 fronts, 2 rights. That's not really helpful. So instead, what I'm going to do is I'm going to navigate to this top viewport here, this second one, on the lower one. I'm going to click that little arrow, I'm going to set view, and instead of the top, let's look at it from the bottom. Okay, so if I zoom out in both of these top viewports, now I'm looking at that same camera, but one from the top and one from below it. I'm going to come over here to my 2 front viewports. I'm going to squeeze one. I'm going to click and drag this little seam in between the 2 viewports to skinny up 2 of these viewports. Here in the front viewport on the far left, I'm going to say set view, and let's call it left. And then on this one, it's already set to right. And then this one on the far right, I'll set view to back. Okay. The next thing I'll do is I'm going to look at my front viewport. I'm going to do a Control A to select all. Okay. Control A is usually select all in many programs. If you're on a Mac, it's usually Command A. And while I'm in this front viewport, I'm going to go to View, I'm going to go to Zoom, I'm going to click on Zoom Extents. Okay, what that does is it zooms in to that object that you have highlighted, or objects, and it's going to zoom in fully in that viewport to that object. The next thing I'm going to do is I'm going to go to View, Set Camera. I'm still in that front viewport. I'm going to say Synchronize Views. Okay. Now what that does, it says All right. Based on the level of zooming I've done in this front viewport to these objects that you have selected, I'm going to make sure that all other orthographic views, all other elevations, all other plan views of these objects are scaled appropriately as the way that we have it here in this front viewport. So if I were to draw an imaginary line from the edge, oops, let's undo that, from the edge of this viewport, from the top view, straight down to this side of the camera in the bottom view, it should line up. I have two parallel lines on either side of this camera. It should line up at the top and the bottom. It should also be the same size here in the front view. This height here is equal in all of my elevation views. Okay? And that's what synchronized views does. It doesn't look at the perspective view at all. It's only concerned with our orthographic views. Is there a question? Yes. My message is split. Like when you like press split view, the button is not even there, or if I type in command. Are you on a Mac? Yeah. Okay. If you're a Mac user, I don't know why, but that is one tool that they decided to sacrifice is creation of many reports. I don't know why. I'm only able to teach you from what I know from the PC standpoint. So if you can't enable that, don't worry. You'll be fine. You'll be able to still Rhino. Yeah, that's okay for the assignment. Yeah, if you're using a Mac, just let me know and tell me that you can't enable that feature. There's workarounds, but I'm not gonna have you do those workarounds. Okay. Did anybody leave any comments? Are there any comments that I need to look at on YouTube? I don't think so. Okay. Now let's get back to our perspective viewport. I'm going to maximize this viewport by double clicking the name perspective. And let's say I want to select a very specific item, or in this case, geometry. Really in Rhino, we're dealing with geometry. There's no actual items here, just geometry. Let's say I click on this shutter button. And let's say I want to zoom into that thing in this view. I would select that item, go to view, zoom, zoom extents. Okay. And what that does is when I say zoom to full extent on that piece of geometry in this view, when I go to orbit or zoom in and out, my camera is now locked on to this shutter button. Okay. That's going to be really handy for you all when you're 3D modeling. Being able to navigate around your model is super important. Zooming into something when your camera is just like way too zoomed out and it won't let you zoom into that item, select that item and type in zoom extent. So that's the basics of that whole exercise. I think we've gotten it all figured out. Okay, any questions on that exercise? Perfect. The next exercise, exercise 3, we're going to start a brand new file. File, new. Save changes to camera, no. And I'm going to start with a small objects millimeters template. Let me go over all of these templates with you real quick. When you start a brand new file in Rhino, you can start it from a various array of different template files. All of these files are situated in such a way where there's specific units being used, a display grid is being used. Between all of these templates, what you want to ask yourself is, am I modeling something smaller than a pickup truck or larger than a pickup truck? Okay, so think of a pickup truck. If I'm going to model a keychain, would it be a small object or a large object? Small. If it was a building, large? Okay, so I think we get the idea. The next thing to ask yourself is what units, what type of units do I want to work with? Here in the great US of A, we use imperial, obviously. So feet, inches, yards, and gallons, and all those great units, that's what we want. Okay. No metric system here. No millimeters, no centimeters, no meters. That's just way too confusing. Okay. We want good old American units. So, those are the big main differences there. And then between two template files, such as these two here, small objects, inches, feet, and inches, versus small objects, inches. In both of these, inches is the primary unit that we'll be using. But in one of them, feet and inches will be the display unit that we see down below as we model. Okay. Feet and inches is great if you're doing something architectural. You're just making little keychains, small objects, inches works fine. Sometimes when you're working with a 3D printer, it actually benefits you to use millimeters, small objects in millimeters. Okay. We'll get to that way later on. So I'm going to choose small objects millimeters for this exercise. We're going to use a command called line segments. So I'm going to go to the curve drop-down menu, line segments. What line segments allows me to do is create multiple lines that are all interconnected in such a way that when I'm done creating all of these lines, the product will be many lines. Right? Not one big long joined connected line, but rather multiple lines. For every line that I created, I will have that many lines. So start of line, way up there in the command line. Right? I've initiated the line segments command. And in the command line, in our command bar up above, if you still have your command bar up here by default, it says start of line. Okay. When using Rhino, you're constantly communicating with Rhino via this command bar. I say line segments, it says, where do you want to get started? I say right here, it says, all right, where's the end of that line? I say right here, it says, all right, where's the end of the next line? I say here, and then we just keep having this conversation until I'm satisfied, right? Once I'm satisfied, I want to end this conversation that I'm having with Rhino. Taking off? All right. So to end my conversation with Rhino, I can just press enter when done, which is literally what it says in the command bar. It says end of line. Press enter when done. You're done talking to me. Just press enter, and I'll know you're not talking to me anymore. So I'm going to press enter. Okay. Now in the command bar, it's just I've just got this blinking cursor, right? Just got a pulse. I don't have any active commands. All of those lines above it, that's my command history. That's the communication. That's the chat that I've been having with Rhino. And now I can go ahead and examine the product of the line segments command. So what did it create for me? Well, if I select these things, I'll see that I have many different lines. In Rhino, we call them curves. So notice that as I select one of these curves by left-clicking one of them, in the command bar history, it'll say one open curve added to selection, right? It's hard to notice because it says it so many times already. But if I were to select two of them at the same time, it's going to say two curves added to the selection. Okay. I'm always watching my command bar. If I initiate something, Rhino's going to talk right back to me. Let's do that command again. Line segments. And I'm going to make a similar shape to what I had done already. But this time, I'm going to use one of these clickable options above in the command bar. Notice in parentheses, it says close and it says undo. So where it says close, there is a small little underscore under the letter C, which means that I can either click that word close and it will close that shape, or I can type in C and hit enter and it will close that shape. Okay. So whenever you see those clickable options in parentheses like that, that just means that you can either click it or you can type in that specific letter of that underscore and then press enter and it will initiate that little clickable option. Yes, let's look at the product. If I go around selecting everything, I still have line segments. So why am I emphasizing this? Let's go and try a different command called curve, line, and we're going to do curve, polyline, and polyline. The way the polyline command works is very similar to line segments, but the end goal, the end result is just going to be one big long joined curve. That could be an open curve or it could be a closed curve. So just like with the line segments command, it's asking for a start of this polyline. I'm going to go ahead and create a very similar shape. It's asking me for my next point and my next point and my next point. Now that I'm tired of having this conversation with Rhino, I'm going to say enter, and I'm going to end this conversation with Rhino. Let's select that thing that I just created. Now it is all joined together. And in the command history, it says I have one open curve added to selection. Okay. Versus all of these separated line segments. Additionally, if I go ahead and type in that command, polyline, create a very similar shape. And this time, instead of typing in C and hitting enter, I'll go ahead and click this clickable option for close, and it will close that shape. And then when I go to select it, it's identified it as a closed curve. So it's a curve that's come upon itself and ends where it had started to create a closed curve. We like closed curves in this class. When we go to laser cut, closed curves are our friends. When we go to CNC, closed curves are our friends. When we begin to 3D model stuff for 3D printing, closed curves are our friends. Okay. How can I take these line segments to, instead of having multiple open curves just sitting near each other, can I turn that into something similar to what I have here with the polyline? I can hold shift and go around and select each one of these line segments or curves, open curves, and I can go to edit, join, and then in the command history it says 7 curves joined into one closed curve. Okay. So now these are both closed curves. We like both of those things. Okay. Those are going to be very beneficial to our process. And then we've got 2 more commands. I've got a curve, interpolate points, which you can find via curve, via freeform interpolate points. Okay, notice that when I move my cursor around in this file now that I have actual geometry sitting here, my cursor is actually snapping to various specific points. A lot of these points you'll remember from that geometry class from a long time ago. Mid, end, near, point, center. All those are very specific object snaps. Okay. Down below in my status bar, I have O snap enabled. These are enabled when there's a blue highlighted background color behind that word. And also that word is bold. So O snap, that's enabling object snap. And then I have my actual object snaps located here on the left side. This is where it usually is by default. These are all my different object snaps. And an endpoint is a point on either end of the line. A near point is any point along that curve or line. Any of these. A point will be an actual 3D point. Mid is the middle of the line. Center is a shape's center, such as a circle's center. And then I've got perpendicular, intersection, tangency, quad, knot, vertex, project, yada, yada, yada. We'll get into those somewhere along the line. But for now, I'm going to turn off OSNAP, which will disable my cursor from snapping to all of those specific object snaps. And in my command line, it says start of curve. I'm going to click here. Next point, I'm going to click here. And I'm just going to continue to initiate new points. And as I do that, a curve is created through those points. Okay, smooth curve with a degree of 3 is created through those points. The difference between that one and a control point curve is that the points that I select are simply influencing that curve, but those points are not necessarily going through the curve is not necessarily going through those curves. You see how all of those points there, let's double click on top view, right? All of those points are there, but they're not at all touching the curve. There's a point here, here, there, here, and here. Right? The curve is not actually going through any of those points versus the interpolate curve. Again, I'm going to hit enter to end that command. Always hit escape 2 times when you're done with the command. Okay, start the command, initiate it, see what Rhino is asking of you in the command bar, do that thing. When you're done with the command, press enter, and when you're totally done, press escape 2 times on your keyboard. Escape, escape. Okay, what this achieves is that it ensures that you've completed that command, and it deselects anything that you may have still selected from having used the command last. Okay, because you never want to keep on going with this process, and while something is highlighted in another viewport that you can't tell from here, you don't want to initiate another command on something that you can't see. It's just going to confuse you down the line. All right. Any questions on this exercise? All right. The next thing I want to do is I want to get us into our coaster file. I want you to start a new file. Give me small objects and in inches. Feel free to follow along if you think you can keep up. However, feel free to wait and be patient until at the end of the lecture, so that way you can just absorb, right? Just listen to the sound of my voice. And just watch the screen in front of you. I'll give you some time in class to create this file. But what we're going to do is we're going to create a very simple coaster that we're going to fabricate in 3 different techniques. One with the laser, one with the 3D printer, and one with the CNC. So here I am in Rhino. I've started a new file, small objects in inches. I'm going to navigate and maximize my top viewport. And the first thing that I want to do is I'm going to create a file for my laser cut version of this coaster. Can anyone tell me the typical diameter of a coaster? 4 inches. 4 inches. That's it. Very good. So, curve, circle. These are all my different options for creating a 2-dimensional curved circle. I can do a center radius circle. I can do it by 2 points, by 3 points, around a curve. I can do a tangent radius, tangent curves, hit points. I'm just going to click on center radius. Okay. And because I've done that, now Rhino's saying, well, where would you like the center of this circle to be? I like to start my geometry, my files, right at the origin. Okay. So I'm going to type in 0. And you could type in 0, comma 0, but even just saying 0 will work fine. So I'm going to type in 0 and hit enter. And that's going to start my circle at the origin. And now the command bar says diameter. And in brackets it says 3/8 of an inch. Okay. I'm actually going to type in 4 because the diameter of this circle, of this coaster, should be 4 inches. And then I'm going to hit enter. So I've just officially made a 4-inch diameter circle here in Rhino. All right, let's look at it. There it is. That's 4 inches, all right. So because I chose the small objects inches template to start with, the grid that I am using uses those imperial units. Every one of these minor grid lines, by default, if you haven't touched these settings, every one of those minor grid lines is 1/4 of an inch. Every one of these bolder major grid lines, both the horizontal and the vertical ones, each one of those is spaced out to every inch, right? So starting at my center, counting to the right, 1, 2, 3, 4 is 1 inch, right? 4/4. And 1, 2, 3, 4 is 1 inch again. So my radius is 2, which means my diameter is 4, right? Basic geometry. So now that I have a circle, I have something that I can use when I go to laser cut. I can now officially go over to the laser cutter, put in some material, and cut this thing out, and I will have a 4-inch diameter circle. So before I do that, let's accentuate it a little bit. Let's give it a, let's say we're going to do this out of plywood. Let's give it a little offset, a little cavity. Type in offset, and then the distance of that offset. Currently, if I look at the command bar, it says distance equals 0.5. That would be 0.5 inches, because that's what the template I chose is the primary units is inches. So let's see what that looks like. Select curve to offset. Well, I only have one curve in this whole entire file, so I'm going to go ahead and click on this circle, and that's where a 0.5 offset is. A 1/2-inch offset. That's a 1/2-inch offset. 1 grid, 2 grids. 1/4, 2/4. 50 cents. All right, that's a little too much. I'm going to click on distance, and let's say 1/8. Okay, that looks kind of clean. A nice 1/8 inch offset. Okay. Now what do I do? Well, notice that if you move your cursor to and fro, that offset is can either occur inwards or it can occur outwards. I want it to occur inwards, right? I don't want to affect the whole entire shape of my coaster. I don't want that coaster to be 4.5 inches or 4 1/4, yeah, 4.5, 4 1/4. So I want to offset inwards. So I'm going to move my cursor in such a way that it's making that yellow curve offset inwards upon itself. And once I find that direction, I just click. Command's all done. Let's type in offset again. I'm going to press enter. I'm going to select this curve to offset, and I'm going to offset it inwards one more time. Okay. Now I've got 3 lines, right? 3 curves, 3 circles. How am I supposed to remember which is what? Which is which? I'm going to start to use my layers over here on the far right. So on the far right, I'm going to change the name of layer 1 by simply clicking layer 1 just once and then clicking it once more. I'm going to call this one laser cutting. And then layer 2, I'm going to call this one score. Layer 3, I'm going to call this one cut. Okay, I've got 3 different layers. Now I can actually take both of these layers by holding shift and selecting both of these layers and click and drag and put them into the laser cutting layer to turn them into sub layers. Now they're both layers within the layer laser cutting. I'm going to select this outer curve. I'm going to right click on my layer called cut, and I'm going to change object layer. Very important little command. Change object layer. And then using that logic of selecting going from right to left, I'm going to select the 2 inner circles, right click on score, change object layer, and now those are purple while the outer one is blue. And what I'm starting to do is organizing this geometry in such a way that once I get to the laser cutter, everything is just spelled out for me. Purple stuff, score it. Blue stuff, cut it. Right? There's a big difference between cutting and scoring. Right? If I were to give you all an X-Acto knife and give you a piece of foam core, and I said lightly score it, you would gently caress that foam core with the X-Acto knife. So it's not to harm it, but just to show it that it's there. Whereas if I told you to cut with that knife, you're going to dive into that foam core and just rip it apart, right? 2 different things. So with scoring, I'm going to tell my laser, hey, laser, fill in this area, or just score these 2 lines just to give me the idea of ornament without cutting all the way through this material. Whereas this blue one, that's the final thing that I want to hold in my hand, right? Actually, I have a few examples here. Right? I want to hold it in my hand. To do that, I need that final cut. And that's what that blue one represents. The next thing I'm going to do is a command called text object. If you just start typing text, you'll get a few selections, a few options here in your command bar. Like, Rhino is so smart. As soon as you start typing a command and it's like, hey, based on the way you're typing this word, it could only be a few of these different commands. We want it to be text object. Okay. It'll open up a new dialog box. You enter your text, change your size. Everybody knows this part. What I want you to understand is your height, Right now, the height is set to 8 inches. I think I only need it to be maybe an inch. So I'm going to type in 1. Choose whatever typeface that you would like. This is going to be very important once we get to CNC kind of stuff. But for now, with laser cutting, we have a lot of liberty. I'm going to leave that. And instead of the word steel, I would like for you to all put your initials. So I'm going to just type in mine, TJC. And then the most important part of this is the output. We have 3 options: curves, surfaces, solids. Most geometry that you can create in Rhino boil down to these 3 different types. They're either curves, which are very two-dimensional things, usually. There are surfaces, where they actually have some sort of planarity to them. And then there's solids, where they're actual thick pieces of geometry, where they have a thickness. As you can see, if I chose solids, I would need to dictate a thickness. If I said 1, it would be 1-inch thick letters that say TJC. For this exercise, for laser cutting, you just need to stick with curves. So I'm going to select curves. I also have group output checked. And then I'm going to click OK. And there we go. Okay. The next part of this trick is picking a point. I need to place this in a very specific spot. So I'm going to just place it somewhere right where I think it looks centered. As you can see, as I move my cursor around, that little point near my cursor keeps on snapping to every grid intersection. And that's because I have grid snap enabled in my status bar. If I turn grid snap off, I no longer have that rigidity as I move around. If I turn it back on, now that point of where those objects are dictated exactly by these grid intersections. So I'm just going to plop it here. I'm not going to be too precise with it. I'm just going to leave it right here. And I've clicked it, and now there's nothing left to do with this command. Now, if I were a coaster, would I want that part scored? Or would I want that part cut through? Scored. Scored. Probably scored. Otherwise, I got 3 big holes in my coaster, right? All that condensation is going to go right through it. I don't want that. So I'm going to say score. Another option for laser cutting is going to be fill. So I'm going to create a new layer called fill. Instead of scoring this, I'm going to fill that. Let's change these layer colors. I've always just done it as RGB, just in that order, just because I'm funky like that. Okay, so for me, score, fill, cut. I also sequence it as score, fill, cut, or fill, score, cut. Cutting is always the last on my mind with this laser cutting stuff. So same thing with the CNC. You don't want to cut the thing out first and then go to decorate it with filling and scoring, right? So if you cut it out first, it's going to drop out of its material. And now it'll be a different distance away from the laser than it should be. So red, green, blue. I'm saying that these 2 red things will occur first. That's a score, that's a score. This part right here, these 3 letters that I've demarcated as green, as fill, I'm actually going to have the laser cutter go in and color that area in, right? Like with crayons. Whereas these 2 red lines are just going to be simply scored, right? The laser is going to go ahead and cut through that material at a very specific low setting that will not cut all the way through. Whereas this blue will be doing the same action, but is going to attempt to cut all the way through. Next thing I want to do is I I'm so nitpicky about these things. I want this TJC. I want it centered. Okay. I don't want it cocked off to the side like that. I don't want it over here. Okay. To do that, we're going to type in align, ALIGN. We're going to select our objects to align. I can select all of these items. I can just select one of these circles. It shouldn't matter. I'm going to press enter when I'm done. And then it's going to ask me what type of alignment would I like to create. Do you want a vertical, horizontal? In this scenario, I want everything aligned both horizontally and vertically. That is a concentrically aligned type. So I'm going to click on concentric. Okay. Notice after I do that, my coaster is just following my cursor around. If I just press enter to auto align, it'll keep everything right where it was, and it'll align everything concentrically within the bounds of all of that geometry. So basically to this blue circle. And that's my laser cut prepped coaster. The next coaster I'm going to create is for CNC purposes. So I'm going to change layer 4's name to CNC. I'm going to make sure that that layer is active by moving that check mark in this column to that row CNC. All we need to do is click in that area where that column and that row align, and now CNC has a check mark next to it, and the word CNC is bold. That means that layer is current. Means if I draw anything right now, it's going to be this greenish color because that's the layered color of my current layer. If I go to the score layer and started creating some geometry, all of that new geometry becomes red because that's the layer color of my current layer. Let's delete all that. And let's go to the CNC layer. I'm going to add a new sublayer. This is the new sublayer button. You can also add just a new layer as well. And for this one, I'm going to call this one a score. And let's add another layer. Let's call it cut. I'm going to take both of these layers, click and drag them into the CNC layer, creating sublayers out of those two layers. Okay, let's make the cut layer active, which is black. I'm going to do the circle command again, curve, circle, center, radius. I am grid snapping right now. I'm going to grid snap to this specific intersection here. Right? As I move my cursor away, I can choose my diameter just by snapping to each one of these grid intersections. In that direction for the radius. Okay. Or up above where it says diameter, I can just say 4 and hit enter. Now I have a circle with a diameter of 4. I'm going to offset. I'm going to select this curve to offset. I'm going to click inside so that way it's pointing inwards. Let's say I'm in the mode of creating many things over and over again, and I'm repeating certain commands, right? There's a way in Rhino to just say, hey, let's do that same command again. I'm going to be doing that command many times right now. Let's just repeat it. To do that, there are at least three different options to do that quickly. Option 1 would be to right click. If you right click in Rhino, it actually will act as you pressing enter, right? So if you're in the middle of a command and instead of pressing enter, you can actually say right click. Same thing. Alternatively, the space bar also acts as the enter button. Okay, so those are three ways to basically say enter. And when you are not in the middle of a command and you want to repeat that last command, you can press enter, right click, or space. Now I'm ready to offset again. Okay, let's hit escape 2 times. I'm going to right click. Now I'm ready to offset again. Let's escape 2 times. Let's press enter. Now I'm ready to offset again. Okay. When you find yourself doing the same exact command over and over and over and over again, you can use any one of those three. So now I'm going to offset. And next I'm going to type in text object. And I'm going to go ahead and output it as curves again. We're essentially creating the same thing as we did earlier. Okay. Notice the two different fonts, two different typefaces. One's skinny, one's fat. Okay. Let's start to organize this into our layers. Let's choose different colors for each one of these layers. So let's start going with cyan and magenta. Layer 5, let's hit cancel. So I want these two circles in here to be a score. Change object layer. And another type of process we can add in here is something called a pocket. In CNC, we can make a pocket. So I'm going to put pocket down here. I'm going to move it down in the layer hierarchy. And instead of white, let's make it CMY. I never use yellow as a layer color because by default, yellow is the color of something that is being selected. It is being highlighted as yellow. So don't ever use yellow as your layer color. Instead, I'll just use orange. And I'm going to say these letters, I want to cut them out as pockets. Okay. So because I'm going to do those as pockets, what's really important with the CNC is that you need to understand what a CNC is. Essentially, a CNC is a computer numerically controlled router, right? If you've ever seen a router, especially a compact router, it has a bit. That bit is spinning in circles, has revolutions, right? It's always going to have a diameter. So if I have an 1/8 inch bit, let's draw a circle for illustration purposes. 1/8 inch bit, that's the diameter. Okay, I'm going to get my gumball on. Okay, I've noticed this yellow circle that I have, or pink, magenta when I'm not selecting it. Notice how small that thing is. This is representative of the actual 1/8 inch bit. That 1/8 inch bit is a very fine bit in woodworking on a router. Okay, looks like it can do this whole entire pocket. Now the issue with using smaller text and smaller font like this, let's choose a different color instead of orange, something darker. All right. So here's an issue, is this dark, that's all the time I have. Okay, we good? So the dark blue part represents the T, right? The top part of the T. This circle here represents an 1/8 inch diameter in the middle bit. So when you hook up to that router, it's the finest that I will use on that router. And look at it, the bit is too big. Therefore, bit would not be able to compute this, would not be able to rationalize this, because it is too skinny of a typeface for us to use. So if I move that circle over here, I'm going to see the similar issues. In addition to those issues, let's put it all the way at this end here. In addition to those issues, in that top left corner over there, instead of having a nice straight 90-degree of a router bit. It's spinning. Therefore, it is circular. Therefore, it does not know how to can't chop things into 90-degree corners, especially inside corners. Outside corners, it can do with enough space, with enough room. But for something like this, creating a pocket, which is a subtraction of material within this region, it's going to have trouble creating sharp 90-degree angles. So instead of using this typeface, I'm going to delete it. I'm going to come over here and I'm going to steal from my own design. Okay, I already chose a nice big fat typeface right here. I'm going to type in the command copy. Press enter. I'm going to select the objects I want to copy, these 3 letters here. I'm going to press enter when done. I'm just reading off my own command bar. Okay, here's the point where it's going to be a little tricky for those of you who are brand new to Rhino. Okay, point to copy from, and then point to copy to. Right? I've said that I want to copy this geometry. Now it's saying, well, where from, what point do you want to copy it from? Okay. And I could just say, well, let's copy it from the origin. So I'm going to type in 0, hit enter. It says, okay, we can copy it from the origin. Now I'm going to copy that thing from the origin. Where do you want me to put it relative to where you copied it from? The origin. And I would want to say, well, put it in the center here. I don't know what that point is. Because I use grid snap, I can count the ways. Say 1, 2, 3, 4, 5, 6. Probably say 6, comma 0. 6, comma 0. Yes, I could do that. Or I could just place it anywhere near and then move it in post using that align, using concentric, right? Or I can start to use my object snaps. So I'm going to enable OSnap. You should always have OSnap on for the most part. I'm using Rhino. And I'm going to turn on these things here. Anything that you're going to learn from this lecture today is these object snaps. These are the ones you should have on all the time. End, near, point, mid, center, intersection, perpendicular. I want you to have all 7 of those on at all times. When OSnap is enabled. There are times when you might disable OSnap so you can create freeform geometry using interpolate curves and such. But when it is enabled, those are the ones that you should have on. Simply enabling OSnap and not having any of these checked, basically OSnap might as well be off. Okay, so make sure you enable OSnap and enable those 7 OSnaps that I just talked about. And then what you want to do is, because I have the center OSnap enabled, I can come in here now and I can find the center of any one of these 3 circles. The center of each circle is the same exact point. So I can find the center of this circle, that circle, or the other circle. Really doesn't matter. So now that I can see it's identified the center of this piece of geometry that I'm hovering over, I can go and click that. Okay. So to find that center, all you need to do is enable OSnaps, enable that center OSnap, and then navigate to the edge or a near point along that piece of geometry, and it'll almost always identify its center. Okay. Once you see that little verbiage right here, CEN, center, you can go ahead and click and rest assured that it'll move it to that center. Okay. So I click once, it's copied it from there, center of this circle. And this command wants to keep going. It's like, all right, we copied it there. Where else do we want to put it? Right? You just say, hey, I'm done. I just wanted to make one copy. Press enter. Press escape 2 times, just in case. And now I'm going to go grab my little circle, which has a diameter of 1/8 of an inch. And I'm just going to move it along without grid snap. And what I'm doing is I'm just testing to make sure that that bit can travel within that area for the most part. Now again, it's not going to be able to create a sharp inside corner, right? It's always going to have a rounded inside corner, but that's okay, at least for the standards of this coaster assignment. The biggest thing I want you to get from this little exercise is that you have an 1/8 inch diameter bit. That's its actual diameter in real life. Just because I can model text that's skinny doesn't mean I can go and CNC skinny text. All right, there are real repercussions. All right, so that's that. You know this one here? Oh, sure. Yes, that's correct. Thank you. Because I've copied this text from here, it is still of this fill layer from the laser cutting stuff. So I'm going to select it all. I'm going to go to Pocket, and I'm going to change Object Layer. And I'm going to delete one of these circles here too. I'm going to delete this middle one here and just keep this one. And basically what I'm going to have my CNC do is I'm going to just say, hey, first I want you to pocket this area out, move wood in this area, within this area. And then I want you to come in here, follow this circle on one side of the circle, or yeah, probably on the inside of the circle, and create another pocket right there, or a score. And then I'm going to have it come here and be on the outside of the circle. Cut that all up to yield a 4-inch diameter coaster. Okay, does that make sense? Anybody confused on that? It's very hard to visualize all this stuff without actually doing it, so don't worry, we'll have time to do it. All right, and lastly for this exercise, I'm going to 3D model a coaster for the purposes of 3D printing it. Okay. So I'm going to borrow the geometry from here. You can also start all over again just like we did for the second one. But I'm going to go ahead and create a new layer. Then we call it 3D printing. I'm going to move it over to the far left so that way it's not a sublayer of CNC, but instead it's our own major layer. And I'm going to select this initial coaster. I'm going to copy it. So I'm going to type in copy. I'm going to copy it from the origin. And I'm going to copy it to, let's turn ortho on. Ortho, turning on ortho in your status bar is going to constrain you to moving straight up and down or straight left and right. Okay, that's what ortho does. It constrains your movements. It forces you to go straight up and down or straight left and right. It can be very helpful. And I'm going to move it right over here, which is about 12 inches away. So I'm going to just type in 12, hit enter, and click once. Hit enter to be done with this command. Hit escape 2 times. You see that just deselected that first copy. And now I'm going to start to do some basic 3D modeling for the purposes of 3D printing. To do that, I'm going to navigate to a viewport where I can see it from a different angle, the perspective viewport. I'm going to select this third coaster. I'm going to go to View, Zoom, Zoom Extents, View, Zoom, Zoom Selected is what I meant. I'm going to say Zoom Selected. And what I'm going to do is I'm going to take this blue part and I'm going to type in extrude curve, or I'm going to use the solid drop down menu. I'm going to go to extrude planar curve and I'm going to say straight. When you're using commands, if you already know, if you can already anticipate the first piece of geometry you need to select for that series of commands, you can go ahead and select it first and then go ahead and find the command. Until then, you'll probably want to just not have anything selected. Navigate to solid, extrude planar curve, and say straight. Extrude planar curve means we're going to take a planar curve, right? A curve to which it's basically flat. It has planarity, right? It is not experiencing a shift in its x, y, and z, or rather just two of those. And we're going to extrude it straight. Okay. Now that I've initiated that command, in the command bar it says select curves to extrude. Now I'm going to select that 4-inch diameter circle. I'm going to press enter when done. And now I have to decide my extrusion distance in brackets. It has a value of 480, which means that if I were to hit enter right now, it would take my 4-inch diameter circle and extrude it 480 inches up into the air, which is just too big of a coaster. What Rhino does is it actually memorizes the values that you've used previously with the same command. So instead of 480 units or 480 inches, I'm going to say 0.25, right? 0.25 inches. Hit enter. And now I have a cylinder. I just have a cylinder. Nothing special about the cylinder. It's just a cylinder that's 4 inches in diameter and a 1/4 of an inch tall. I could go 3D print this, and voila, I have a coaster. A little boring, right? I want to custom make my own things. I want it to be branded. I want it to have my initials on it. I want to sell it for $1. So what can we do? I'm going to start to be subtractive now. Okay? We're going to start to take away from this basic shape. And the shapes we're going to use to do it are these ones here. Okay? So notice that these curves are sitting atop the face of this cylinder, right? The top face of this cylinder. The what? The bottom looks very similar to the top. Okay. The only difference is that the top has these curves sitting right on top of that face of the cylinder, right? Much like our Rhino basics exercise that we went through. Right? We had the cone, the cylinder, the cube, sphere. They all sat on top of a very thin little surface. And when we orbited and were below that surface, we could see the subtle outlines of those shapes, of the bases of those shapes. But it wasn't until we got to above it that we could see that they're all sitting on top of it. So now to start to subtract, I'm going to select these. I'm going to do it the longer way, actually. I'm going to say solid, extrude planar curve, straight. Select curves to extrude. I'm going to take these two offset circles here, right? Not the big 4-inch diameter ones, but the two offset ones I'm going to press enter. And I want to come about just about there, 3/16 of an inch. I want to come 3/16 of an inch downwards towards the bottom of the cylinder. So I'm going to type in 3/16. You can put a little quotation mark. Okay, quotation mark means inches and imperial units. But also you can skip putting in quotation marks because our primary unit in this template is inches. So really 3/16 of a unit is 3/16 of an inch. Okay, so I'm going to type in 3/16. If you put in a quotation mark, that's fine. No biggie, it'll still take it. And I'm going to press enter. All right. I'm going to orbit around this coaster. I'm going to pan. All right. I don't see any difference. Does anybody know what I should see? What should I see? Should I see anything different? What did I just do? Not yet. No. I just took these two circles here, these two-dimensional circles. I did an extrude curve, and I extruded them straight down, 3/16 of an inch. Right? The reason why I can't perceive that new piece of geometry is because the face of that new piece of geometry and the face of this 4-inch diameter, quarter-inch thick circle are planar. Okay. If I were to select that outer coaster, use the gumball to move it down, voila, there is that ring. The top of each one coincides, right? They're both planar. I'm going to hit undo. Okay. Now, if you zoom in and start to orbit to and fro, one important thing I want you guys to notice about your geometry in Rhino is when these two faces coexist in the same exact plane, as you move your camera around that thing, it's going to look really glitchy, right? And that's because they both share just a little bit of area. Okay, that's how I know this little piece, this extrusion here, sits and is embedded into the bigger one there. So why did I do that? It creates no difference in the actual overall output geometry. I did it because we're going to use it as a means of subtraction. We're going to use Boolean difference, a very important command in Rhino. So, solid difference. The command itself is called Boolean difference. Whenever you type in commands in Rhino, they're always one word. Even if it's actually two different pieces of verbiage, they're all squished together as one mega word, one command. Boolean difference. Okay? The way Boolean difference works. And you can read it right there. It says select surfaces or polysurfaces to subtract from. Okay, I'm going to show you how this works, and then we'll start over. We'll do it again, and I'll explain it slowly. So select surfaces or polysurfaces to subtract from. I'm going to select my big 4-inch diameter coaster, quarter-inch thick. Now if I go back to my command bar, it says select surfaces or polysurfaces to subtract from. Press enter to continue. Actually has new verbiage now. So I've already selected the thing I want to subtract from. I'm going to press enter. Now it says select surfaces or polysurfaces to subtract with. I'm going to select that inner ring that I extruded 3/16 of an inch. My command line says select surfaces or polysurfaces to subtract with. Press enter when done. I'm done, so I'm going to press enter. And now you you can really see what it does, right? It takes two solid poly surfaces, and wherever they coexist, I can say, hey, wherever they share that area, get it out of the main one, right? So the from was the big 4-inch circle, 4-inch thick. The two was that inner two circles, 3/16 of an inch thick. Does that make sense? I subtracted B from A, right? A being the big one, B being the smaller offset inside of it. So let's undo. I'll use different colors this time, and I'll call it blue. Okay, now you can really see that glitchiness, right, of these two areas sharing the same exact area, right? It's kind of pretty. So Boolean difference is the command. Boolean difference. Press space bar, enter, or right click. Select surfaces or poly surfaces to subtract from. I'm going to select that 4-inch pink circle. Press enter to continue. I'm going to select the blue poly surface. Press enter to continue, and that'll dig out 3/16 inch trench in my coaster. So let's do that same technique, but now with these three letters, right? These three curves, these three letters are just curves, right? They're not solids yet. So let's make them solids. I'm going to extrude curve. That's the command. Or solid, extrude planar curve, straight. Same thing. Extrude curve. Or solid drop line, extrude planar curve, straight. Everything is organized into all of these drop-down menus. Do you need to change the shape of something? You're going to transform it. Go to the transform drop-down menu. You'll see some different techniques of how to transform that thing. Do you need to view something very specific? That'd be in the view drop-down menu. Do you need to create some curves? That'd be in the curve drop-down menu. Okay. Most of the commands in Rhino are organized into those drop-down menus. I want you to pay attention to the names of those commands as you find them. Because eventually you're going to get so quick and so fast at using Rhino, instead of using any of these drop-down menus, you're just going to be typing all these commands in and clicking away. Super quick. Okay, so solid, extrude planar curve, straight. Let's see, I'm going to extrude my 3D letters to be, let's say, 1/16 of an inch. Okay. What is the command I should use to subtract those 3 letters away from the rest of the coaster? Bueller. Bueller. No? Nobody? Boolean difference? Just went over it? All right. Boolean difference, you guys. We just did it. We're going to subtract from. Which one are we subtracting from? The coaster, correct. Press enter. And then what are we subtracting with? The 3 letters. Thank you. Press enter. Now there are 3 little sockets where those 3 letters are. Okay. I don't want those to be too deep because I don't want to place my glass on the coaster and it tip around. Okay, so I'm going to keep it nice and shallow. But this trench around it, I'm going to leave it at that depth, right? Because that's where all the condensation is going to go. It's going to drift over there. Keep my table dry. So these are the 3 methods for creating coasters for 3 different fabrication techniques. In addition to all of these 3, there are 3 separate ways of going about to fabricate these things with those specific tools. I'm going to give you guys some time in class to create your coasters. And we have about an hour left, which I don't really think is going to be enough time. We might have to come back and reconvene next week, where I'm going to start to put you in your groups. Okay? So please, next week, when you come in, I want you to sit near some people that you think are friendly. All right? As evenly as we can. That way, I can put you all in a group. That'll be a group. That'll be a group. And then this group will 3D print, this group will laser cut, the other group will CNC. And then we'll be rotating. You guys are going to make coasters in 3 different ways within the next 3 weeks, just to get an understanding of how each of these tools work, right? We're going to forego the design part. We're just going to make a simple circle with our initials in it. Super basic design. The idea is to understand at an introductory level how each one of these tools works. After each of your groups take a visit to each one of these tools in about 4 weeks, then we're going to start to challenge you on your design capabilities. And by then, I'll have assigned you some other Rhino level 1 training exercises to help build up those techniques. All right. Any questions? Is there anything left in the chat or anything before I end our lecture? Anything else? All right. Get to it.